So in this video, we'll be doing the topic of complex numbers. So let's begin with the first topic, that is algebra of complex numbers. Now, under algebra of complex numbers, first thing that we need to know is the definition of complex numbers. So how do we define a complex number? So basically, you can say any number of the form a plus ib, where a and b are real numbers and I is equal to root of -1 is known as a complex number. Is known as a complex number. This is how you can define a complex number. And usually to denote a complex number, we use the symbols like Z, Z1, Z2. So you can just say complex numbers can be represented. Numbers can be represented using symbols like Z, Z1, Z2, W, alpha, beta, omega, etc. So this kind of symbols we can use to denote complex numbers. So now, therefore, let us suppose we represent the complex number a plus ib with the symbol Z. Let Z is equal to a plus ib. Then this a is called real part of complex number. So you can just say real part of Z. Real part of Z is defined as a. So we usually write real part of Z. In short form, we write RU of Z is equal to a. And the presence of I makes this imaginary. But when you write the imaginary part, we just write b only. So imaginary part of Z, if I had to write down, we can write this as Im of Z, and that we denote with the symbol b. So you can also therefore write Z is equal to real part of Z plus I times imaginary part of Z. This is how you can denote a complex number. Now, when I say a complex number is purely real, so if I say Z is purely real, this implies imaginary part of Z would be 0. And we come across these things while doing problems anyway. And if Z is purely imaginary, so purely imaginary, so this implies real part of Z would be 0. So they combine this concept with some trigonometric equations concept. That is, when you equate imaginary part of Z with 0, real part of Z with 0 in a problem, you will usually get a trigonometric equation which you need to solve and find out the values of theta, which are in a specific interval, or sometimes they may ask you to find a general solution. So when we do problems, anyway, we'll come to know about it. And now also, if Z is a plus ib, then if you replace I with minus I, you get a complex number called a minus ib. This we usually denote with Z bar. So Z bar is equal to a minus ib is known as conjugate of Z. Just like conjugate of a surd. In surds, when there is an irrational term, you change the sign of that to find its conjugate. In the same manner, in a complex number, you change I as minus I, then you get conjugate of the complex number. Z bar equal to a minus ib is known as conjugate of Z. This is called conjugate of Z. Now, having known this now, if you add Z and Z bar, you will get 2a, and that is nothing but 2 times real part of Z. And if you subtract Z and Z bar, you get 2ib, and that is known as, what do you get? 2ib, that is 2i into imaginary part of Z. So we can also write real part of Z as the complex number plus its conjugate by 2, and imaginary part of Z as the complex number minus its conjugate by 2i. So real part of Z equal to 0 means Z plus Z bar is 0, and imaginary part of Z equal to 0 means Z equal to Z bar. This is what you get, and this can be correlated with this one that we have already written. Okay, this is about the conjugate. And after knowing these things, we need to know how to do algebraic operations on complex numbers. Algebraic operations on complex numbers. Right now, we'll not use geometrical method. We'll be doing that under inequalities involving modulus. So we'll just see how to add them directly like we do in real numbers. So if there is a complex number Z1 as a plus ib, and one more complex number Z2 which is c plus id, if these are the two complex numbers, if you have to perform addition of complex numbers, It is similar to real numbers. But while adding the complex numbers, you'll add real part with real part. So we'll add A with C, which is real part, and IB with ID, which are both imaginary, taking I common. So this is the new complex number after adding them. So for the new complex number, A plus C is the real part, B plus D is the imaginary part. And similarly, if you have to do subtraction of complex numbers, you want to write Z1 minus Z2, you need to subtract real part with real part in the same order, like A minus C plus I times B minus D. This is how you write down the difference of two complex numbers. Now let's see how we can do multiplication of complex numbers. Now coming to the multiplication of complex numbers, suppose you want to find Z1 into Z2, then this is A plus IB multiplied with C plus ID. We just multiply like normal real numbers, group the real parts together, imaginary parts together, and write the result. So we'll multiply A with C, so AC, then A with ID, AID, and I with BC, so IBC, then IB with ID will give I square BD. So the AC term doesn't have I, so this is real. This I square will become -1, so that will become minus BD, that is also real. Write them together. And these two will be imaginary parts, so write I into AD plus BC. So this is how you write down Z1, Z2. So for Z1, Z2, the real part is AC minus BD, and the imaginary part is AD plus BC. This is how you multiply complex numbers. And finally, coming to the division operation in complex numbers. If you have to perform division of complex numbers, that is Z1 by Z2, which is A plus IB by C plus ID. So usually we multiply and divide with the conjugate of denominator and try to make the denominator real always. So the conjugate is C minus ID. So in denominator also we'll multiply with C minus ID only. So in the denominator, C plus ID into C minus ID, C square minus I square D square. And in the numerator, if you multiply these two, this is just like A plus ID into C plus ID, but only difference is D is minus D here. So whatever result you got, write the same thing with D replace with minus D, this will become AC plus BD. Since we already calculated, I'm not doing again. Plus I into, in the second one also, you got BC plus AD, replace D with minus D, that will become BC minus AD. So wherever D is there, change as minus D. And now separate out the real part, that will be AC plus BD divided by I square is -1, so denominator becomes C square plus D square. Similarly, this also gets divided for second term. So I times BC minus AD by C square plus D square. So for the new complex number obtained after division, this is the real part and this is the imaginary part. That is how you divide complex numbers. Now, after this algebraic operations, we have something called laws of complex numbers. What laws do complex numbers obey? So the first law is the closure law. So what it states is if you operate on two complex numbers, Z1 and Z2 belong to the set of complex numbers, then if you add complex numbers, the result will be complex. Z1 minus Z2 also will be complex. Multiply them, you are getting a complex number. Dividing also will give you a complex number. That means with reference to all the algebraic operations, complex numbers obey closure law. Hence, complex numbers obey closure law. Complex numbers obey closure law with respect to addition, subtraction, multiplication, and division. Addition, subtraction, multiplication, and division. Multiplication and division. So if you get a quantity which is not a complex number, that is, you operate on complex number, you don't get a complex number, then we say closure law is not obeyed. So in general, if you operate on two quantities and you get a quantity of same type, we say closure law is obeyed, otherwise closure law is not obeyed. The next law that we have is commutative law. So this is valid for addition as well as multiplication. So what it states is, if Z1 and Z2 belong to the set of complex numbers, then Z1 plus Z2 is same as Z2 plus Z1. If you change the order of addition in complex number, the value will remain the same. And similarly for multiplication also, if you change the order, the product would remain the same. This is called commutative law of complex numbers. With two complex numbers, we write this. And then coming to associative law of complex numbers. So if you operate on three complex numbers, so let's say we have three complex numbers, Z1, Z2, and Z3. If Z1, Z2, Z3 belong to complex number, then so you add Z1 and Z2, add the result with Z3, or add Z1 with the result of adding Z2 and Z3, the value will be the same. So basically you can add in any random order, it's not going to change. But generally we write associative, we write like this. Then apart from this, we have to discuss something called distributive law, identity law, and one more law called inverse law. So we'll also discuss that. So the next law that we can write is nothing but the distributive law. So what does the distributive law state? So if there are three complex numbers Z1, Z2, Z3, then this law states that Z1 into Z2 plus Z3 is same as Z1, Z2 plus Z1, Z3. This is called left distributive law. And Z2 plus Z3 into Z1, you write Z1 after this, then this is called right distributive law. You can write Z2, Z1 plus Z3, Z1. So the first is called left distributive law, second one is called right distributive. And coming to the next rule, we call it as identity law. So what does this law state? So this law states that if Z belongs to complex numbers, then if you add 0, 0 is also a complex number, Z 0 to Z or Z to 0, the result will be Z only. So this is called identity law. And what is 0 called as additive identity for complex numbers? We call it as the additive identity for complex numbers. And coming to the sixth one, this is called inverse law. So what this law states is, if Z1 and Z2 are two complex numbers, then if you add Z1 and Z2, get the result as 0, then Z2 is known as additive inverse of Z1. Z2 is known as additive inverse of Z1. Additive inverse of Z1. So Z2 equal to minus Z1. And if Z1 is A plus IB, this implies Z2 will be minus A minus IB. This is called as additive inverse. Now just going back, just like I wrote identity law in addition, we can also have an identity law in multiplication. If you multiply Z with 1 or 1 with Z, you get back Z only. So this is called identity of multiplication and 1 is called multiplicative identity for complex numbers. 0 is additive identity and 1 is multiplicative identity for complex numbers. So based on this, we can again write inverse law even for multiplication also. So you can just say that Z into 1, Z, if suppose you multiply Z1 with Z2 or Z2 with Z1, if you are getting the result as 1. So then this is called inverse law of multiplication. And Z2 equal to 1 by Z1, if you write down, this is called multiplicative inverse of Z1. So 1 by Z1 is multiplicative inverse of Z1. So 1 by Z1, what is it called as? Multiplicative inverse of Z1. Inverse of Z1. So that means if they give Z1 as A plus IB and you're asked to find out the multiplicative inverse Z2, you write 1 by A plus IB. But we usually don't leave like this. We multiply and divide by the conjugate A minus IB. And then we can write this as A minus IB divided by, in the denominator, the product will be A square minus I square B square. Writing I square as minus 1, you can write this as A by A square plus B square plus I times minus B by A square plus B square. Negative sign you can write here. This is the multiplicative inverse of A plus IB. So that's about the laws of complex numbers. These are the laws we can write for complex numbers.